Hi there. In this video, we're going to go through a whole hypothesis test example. This is a story about a flat tire, and I've explained the first part of the process, so we're going to go through all that, and then I'm going to go through the second part, but I'll explain that part in more detail, okay? All right, so flat tire example. This is a story. I don't know if this is true or not, but I think it's kind of a funny story. A story of on a college campus where two students miss a chemistry test because they were partying too much, but they blame their absence on a flat tire, okay? So they tell the story to the professor. The professor allowed them to take a makeup test. He sent them to two separate rooms to take it. The first question, worth 5 points, was pretty easy. The second question was worth 95 points, and it said, which tire was it? So this is kind of like, splitting up the people into different rooms scenario that you might see on detective shows and stuff. So I don't know if this ever actually happened, but it's a funny story to me. I don't know if it's funny to you as a student, probably maybe not. It turns out, so statistics teachers have been using this for simulations and gathering data from students, and it turns out there is a tire most picked out of the four. So which one do you think it is? Do you have a guess? In a survey of 100 students, 30 said the right front tire. So I think, and I need to gather more data on this myself, I think that more people tend to say the right front tire. That's not what I picked the first time. I picked the driver's side tire. I don't know why, but so we're going to test this claim. So in a hypothesis test question, we're always looking for what's the claim. We're going to test the claim that it's more common to choose the right front tire at the 5% significance level. Okay, and then we have in our survey, so this is our observed result, is the 30 out of 100. Observed result. Okay, so let's start with our first step. What's the parameter of interest and what's the direction of the test? Use this to write the hypotheses. So our first step is to write the hypotheses, but in order to do that, we got to figure out, is it a mean or a proportion? Or later, is it two means or two proportions? And is it right tail, left tail, or two tail test? What's the direction? And that's going to help us write out our hypotheses. Okay, so what's the parameter of interest? So it can help to think about, is it numerical or categorical, right? We've already had a lot of situations where you have to choose the parameter, which is it P or is it mu? Okay, so if you said P, you're right, because this is like a yes-no, right? Did you choose the right front tire or not? Or did you choose one of the other three? So we're focusing on one, which is the right front tire. And another way to tell, so choose the right front tire, this is a yes-no question, and then our statistic is 30 out of 100, so that's a proportion also. So that tells us it's not an average, like 40 pounds or whatever. So our parameter is P. Okay, so that helps. And then we can start setting up our hypotheses and see what happens. So H naught or H null, and then the colon. We always start, if our parameter's P, we start P equals. Okay, now we need a value for this. So this is, sometimes it's given to us, but this time it's not. And that's because this is like a random process parameter. So I'm going to write random process under here. So this is similar to the Kiki Booba test, but I wanted to choose one that wasn't 50-50. So if we're looking for right front and people are just guessing at random, what's the chance of guessing that one tire? If you said 1/4 or 25%, you're right. So P equals 0.25. Okay, and I'll just write a note over here. We have 4 tires. So 1/4 chance of guessing right front. Okay. Now we can do our alternates, and that's going to be HA colon, and we still have P. We're always testing, it's one test, so we always have the same parameter. Now this one will be either greater, less than, or equal, or not equal to, because this one's equal. So that's where we look at the claim, okay? And the wording of the claim is test the claim that it's more common. So more common is going to be over to the right on the graph. So that's greater than 0.25. And these always have the same number, okay? It's just the symbol in between that's different, the inequality or equality symbol. And just to make a note, that means our P0 is 0.25. Sometimes we refer to that value. Okay, so there's our hypotheses. You don't have to box them, but I have a lot of notes there, so I'm just putting a box around them. Let's look at our next step. Using an appropriate randomization applet, so that means we've got to pick one for proportions, right? Enter the observed statistic and simulate the randomization distribution for the sample size used in the study. Okay, so now is when we get our randomization distribution. And then we're also going to use that in the next step to find an approximate p-value. And then this is where I haven't quite explained all of that, so I'll explain. We're going to go through this whole example, but then I'll explain more about C, D, and E in the next video, okay? Just take little parts at a time, because there's a lot to this. Okay, so using an appropriate randomization applet. Okay, so I'm going to go over to Rossman Chance, and there is a reset button on the bottom left, okay? You can tell I was trying this one already. So normally it comes out, they didn't reset everything. I'm just going to reset it by going back to one proportion inference. Okay, so normally when it comes up, you'll be at 0.5 because this is like the coin flip scenario, right? So what we're going to do is change it to our null, right? So we're simulating the null. 0.25, there's a 1/4% chance, or not a 1/4%, a quarter chance or 25% chance of guessing a particular tire, okay? Now, if we were testing whether the two students picked the same tire, that would be a different test. So I'm kind of curious to investigate that one as well. But for now, we're just looking at what's the chance of guessing one of the particular tires, okay? Right front. Okay, now this one, when you go off of 50-50, a coin doesn't work anymore. So they go to spinners. So I'll just do one show animation. And here's where we need our sample size. We have 100, we have a survey of 100 students. So we need to look at all random samples of 100, right? To see how likely is it that we got that 0.30, okay? So I'll just do one sample first. And it's really hard to see the 100 spinners, but you can see at the end, there's a quarter, or maybe you can see over here. If you look at this, just think of the circle on the end, there's a quarter of it is blue. So that's 1/4 of each of this for each tire. Okay, so that's one simulation. I'm going to stop the animation, but just draw a couple more. So in this survey, it was 23 out of 100 said right front. This one, 23 out of 100. Ooh, only 15 out of 100. 19 out of 100. 31 out of 100. 21 out of 100. Okay, so I'm up to 8. I'll go to 10. And then we just want to get around 2,000. So you could do 1990 if you want to get exactly 2,000, or I'm just going to go to 2,000. And I got to click on Draw Samples. Okay, we get our familiar. You can hide the spinners if you prefer. We get our familiar normal shaped curve, right? And if you want to double check, you can even click on this normal approximation and see how close it is. So it is quite close to a normal model. Okay, and so this is called our randomization distribution. It's like the null world. Some people call it the null world. This is the distribution if the null is true. Okay, so if it is exactly, let me change this to proportions. If it is exactly, 25 people are guessing randomly, then it would be 1/4 chance of guessing the right front. Okay, so then, but we had 30 out of 100. So that is more than 25%, but is it statistically significant? That's our question. Okay, so we're going to count the samples as extreme as 0.30, and then this count is not like the count, it's the verb to go ahead and count how many were over 30 and over in all of our simulations. So 321 of the 2010 simulations were 30% and over. So it's actually not that rare, right? It's 15, almost 16% chance of that to occur. So this is actually not a significant result. It's not small enough where we say, wow, that's super rare under the null. So that provides evidence for the alternate. Okay, let me go back to the paper because I have this on the paper for you. But before I do that, I just want to write my p-value down here, 0.1597. Okay, before I forget. Okay, so we did our applet. Let me just write on here because we used our observed statistic. That was our p-hat, was 30 out of 100, or 0.30. We did our randomization, and so our n is 100 for that also. That's what we needed for that. We found our randomization distribution. This image on the left is the Rossmann chance applet. So you can use either one. Doesn't matter to me if you have a preference. You can use either one. You don't have to use both. And this is a little typo down here. This is random samples of 100. So this is all the random samples of 100 where people are guessing with 1/4 rate, 1/4 chance of choosing the right one. Okay, so this is our p-value. Okay, and I'll explain a little bit more about that. And then we used greater than because this is a right tail test. Right, so in our claim it said, is it more common to choose the right front? So we want to know when did people choose that one more than chance, right? Or more than 30%. So you might be wondering, why don't we just look at 30% by itself? But what if a sample had, 33% said the right front, or 36% said the right front? That's all evidence for the claim. So we want to count everything from our value and toward the tail, because everything more than that is also evidence for the claim, even though it's not evidence, even though we didn't get that particular sample. There's a 15.97 chance of getting 30% or more saying, oops, I didn't change this one to proportion. I should have done that. There's a 15.97 chance of 30 out of 100 people or more saying that, choosing the right front tire. Okay, so that's our p-value, 0.1597. I'm going to write that under here, p-value. And remember, I'm still going to explain more about what that is after I finish this test. Let's go ahead and do it in the StatKey applet. And here I got 0.144. This time I did it, so let's see what I get this time. And if you know which applet you want to use, you don't have to watch the video for both of them. You can skip around and use the one you want. So here is StatKey reset plot. And I'm still going to go in because I normally would have to change my null hypothesis to 0.25 in this case. That's our null. And then I need to hit edit data and put in our observed statistic 30 out of 100. Okay, and I can double check that that's correct on the right side. It has my sample proportion or observed proportion here. Okay, that is all we need to do to set up this one. So the setup might be a little bit easier, but I did a couple, showing you the spinners on the other one, which you don't have to do. You can go right to 2,000 samples if you want. And here I'm just going to click 1,000 and then 2,000. And note, you can also choose count or proportion on this graph as well. So I'm going to keep it as proportion. And then this one I like because it has null equals 0.25. So that's referring to our null hypothesis. And to get our p-value on this one, we need to know, is it a left tail, two tail, or right tail test? And just like we talked about on the Rossmann chance, we did greater than. So it's a right tail test because we're interested in 30 or more as evidence towards the claim that it's more likely to choose the right front. Okay, now this, remember, always comes up at 2.5%. It's using that middle 95. So we need to go ahead and change that to our 0.30. Sometimes there's a little lag on this one. I wish it would just come up with our sample proportion there, but we have to type that in ourselves along the horizontal axis. And then the number up above, that's our probability, or how many, the proportion of all these red X samples in the right tail were 30% or more. And that was 0.146. So I'm going to write on the StatKey graph over here, 0.146. Okay. So they're similar but slightly different, okay? But none of these are super rare to get under the null. So this is not statistically significant. Okay, so let me explain more about that. I'll write out how we would write it, and then I'll show you more in the next video. Okay, so this says, compare the p-value with the significance level alpha and determine whether the result is statistically significant. Okay, so let me go back to the question. Right here it said, test the claim at the 5% significance level. So that's alpha, or 5%. So what that's saying is, if something's rare if it's less than 5% likely to happen. This was not rare because it was 14 to 15% likely to happen, okay? So I'm going to write the p-value equals 0.1597, and I could choose any of these four numbers. You're only going to do it once, but I've done it many times now, actually. So I'm just going to pick any one of them. And then I'm going to write, this is greater than 0.05. That's our significance level. So this result is not statistically significant. Okay, so what that's saying is it's fairly likely to happen due to chance. Okay, and another way to say it is it's evidence for the null, not the alternate. Because it's not super unlikely. Okay, so small is significant, and I'll get into that in the next video. But let me just show you how we would write out our conclusion, and I'll explain the more details of the last 3 steps, and then we'll do more examples. Okay, so we're always going to state our conclusion in context. We can never make assumptions that anyone knows what rejecting the null or failing to reject the null means, so we need to write it out in the context of the question. And we're also going to include the p-value, okay? So I actually kind of wrote part of my conclusion up here already, so I'm going to repeat that part with a p-value of 0.1597. Our result is not statistically significant. Really wish that was a shorter phrase. It's a lot to write out, spell out. Our result is not statistically significant. So in this case, we fail to reject the null. And we do not have evidence to support the claim that, and then here's where I put in, I go back up to what the claim was. What were we testing? Test the claim that it's more common to choose the right front tire. Okay, so we do not have evidence to support the claim that it is more common to choose the right front tire. And I could also say over the other 3 tires. Okay, so that's one way to write it out. And then I'll go over the more details of the last part in the next video. I'm curious, so it sounds like, you know, I picked 30 out of 100 because I wanted to show you one that was not significant. I'm not sure if there actually is a, if it actually is more common, so I'm going to have to do some surveying of students to see if it is more common to pick one tire over the others. But okay, hope you've enjoyed this video, and I'll get into more specifics of the last steps in the next video. So I'll see you there.